Hello everyone, welcome back. In this lesson, we will see how to extract the features from the face using deep neural networks. Open face feature extraction method is one of the most popular way of extracting the features. This is the architecture flow that was used for extracting the features using the open face method. We will see step by step like how this is going to be work. Step 1 in the feature extraction is to detect the face. We can apply whatever the technique you want, like hair cascade classifier, or you can also apply the deep neural networks to detect the face. Once you detect the face, next step is crop the face, that is with the help of NumPy slicing. Then for the cropped face, we need to apply shape predictor model that will actually identify the landmarks in your face. Basically, the facial key point. It will identify the position of your eyes, nose, chin part. The shape predictor of the face is passed to the deep neural network, and that is going to return you the 128 dimension unit space hypersphere, which is basically the features of the face. And this can be used for the clustering, similarity detection, and classification models. Face recognition is one of the application of the classification. In this project, we are working on the classification model, means we are going to take these features and apply to the classification algorithm so that we can get the face recognition. Here you can find the reference of the open face feature extraction method and the URL is given there. You can have a look into the official documentation of the open face. I will see you in the next lecture on how to extract the features from the face using deep neural networks. Until then, happy learning. Hi, welcome to the section Face Detection and Feature Extraction using Deep Neural Networks in OpenCV. In this section, I will teach you how to do automatic face detection, facial key point detection using Deep Neural Network module in OpenCV. Here, we will use deep learning models to do this process. Let us look into the output of the section. Consider the image of the girl. For this image, we will do face detection, landmark detection, that is facial key point. And using those landmarks, we will extract the features, that is 128 vectors. This will be the important for the machine learning model to build the face recognition applications like person identity, gender detection, emotion detection, and many more. Let us get into the section to get more details about this. I will see you inside the section. Hello everyone, welcome back. In this lesson, we will see the feature extraction from the face using deep neural networks. So let us import the libraries, that is NumPy as NP. Also import CV2, and this time I'm introducing the new library which is dlib. dlib is the most powerful library, particularly for the feature extraction process. Going forward, we are not using the dlib, we just use in this particular lecture only, just to try to understand what exactly the feature extraction process. Also import face utils from imutils. So from imutils, import face underscore utils. Execute it. Oh, it is utils. Execute it. Now consider the image which is girl.png. img equal to cv2.mread and the name of the image is girl.png. Done. So let us display this image. You can display the image by using cv2.mshow, and this is the girl and img. Now cv2.wait key, just mention 0 and cv2.destroy all windows. Execute it. Okay, this is what the image we are considering now. For this image, what we will do, we will detect the face first, then we will identify the shape and we will extract the features. So the 3 steps are going now. Let's start it. So first let's import the models, which is shape predictor, and also import one more model which is face descriptor. which is so shape underscore predictor. I'm using the dlib library, dlib dot shape predictor, and provide the model to it. The model that I'm going to provide here is in the models folder, and it is a shape predictor underscore 68 underscore landmarks dot dat file. So this is the model I just want to load into the shape predictor. And similarly for the face descriptor, and the model that I'm going to use is shape descriptor equal to dlib dot face recognition model underscore v1. Now I just want to provide the model, another model to it, so which is face recognition model ResNet model underscore v1. So this is what I just want to provide to this. Done. Let me execute this. We have successfully loaded our deep learning model. Now let us start the process by extracting the features from the face. The first step in extracting the features from the face is face detection. So the step number 1 is face detection. There are different ways of detecting the faces. So here what I will do, I will use the simple dlib library, and using the dlib library I will show you how to detect the face. Alright, let's start now. Now what I will do, let me copy the image whatever I loaded into another variable image equal to img.copy. Now face detector equal to dlib. In dlib we have a default frontal face detector is available, so I will use straight away in this lecture. So get frontal face detector. Now faces equal to face detector, which is from the dlib dot now apply to this image, which is image, which is my image. So that's it. So now what I can get here is that, like, we can get the faces here. You can print the faces and have a look into that. And here you go, what I can see is that, like, this face detector is returning the output in the terms of rectangles. It gives you that xy, it gives you the bounding box positions. This is the xy position, and this is another diagonal position to this point. Now let us run a loop and draw a bounding box on top of this using this rectangles. Let's run a loop for box and faces, and what we can get is basically this box is basically consists of the rectangle, even though you might have the multiple faces. So that's the reason I'm running in a loop. So here you go, what we can see is that we got this box. Now let me take this point 1 and point 2. This is my point 1 and this is my point 2. So in order to get this point 1 and point 2, pt1 equal to box dot left comma box dot top, which is what my point 1, and similarly the point 2 will be equal to box dot right comma box dot bottom. So that's it. So what we got here is that the point 1 and the point 2. Now let's draw the bounding box on top of this using the rectangle in OpenCV. So cv2 dot rectangle, and what we need to provide here is this image. Next is the point 1 is pt1, and the diagonal one and another diagonal point is pt2. Next is color. Let me give the green color 0,255, 0, and thickness let me set to default. Now what I will do is that let me display this image using mshow. This is what my girl face detect. Now the name of the image is img, and cv2 dot weight key of 0, and cv2 dot destroy all windows. Execute it. Here you go, what you can see is that we can able to detect the face and draw the bounding box on top of this. Cool, right? I think we already made this process. I know that there is not much interesting stuff in this. Now what we will do, we will try to identify the shape of the face using the shape predictor model. That will be the much more interesting stuff. I will see you next lecture on that. Until then, happy learning. Welcome back. In the previous lesson, we have seen how to do the face detection using dlib. Now what we will do is that whatever the face we have detected, we will calculate the landmarks of the face using the model shape predictor. So here I'm using this model shape predictor. In using that, what I will do is that I will try to find out the landmarks of the face. Now face underscore shape equal to shape predictor. This is the model I just want to take, and shape predictor, what I need to do is that I just need to pass image and the box of this. So image is image and the box is box. That's it. So with that, what you can get is that we can get the landmarks of the faces. Since this is in the dlib format, in order to convert that into numpy array, what we will do is that we will take this face utils. Okay, so now face underscore shape underscore array equal to face utils dot shape to np. Basically, we are converting that into numerical Python. And what I need to do is that I need to provide the face shape to it. So copy and paste it here. That's it. So now you guys are ready and we got the landmarks of the faces. Let me print this. Print face underscore shape underscore array. Execute it. And here you go. This is what the face, and this and all the corresponding landmarks of the face what we got. And remember, these and all the points means 113 and 249 together is 1 point. So like this we have 68 landmarks out there. What we can do is that we can use these circles and create the circles on top of the face, and what you can get is the landmarks. Now in order to create a circle, I'll use a for loop for points and face underscore shape underscore array, and I just need to create some I just need to create a circle here. So circle is cv2 dot circle, and what I need to provide is image, and next one is center of the circle. Obviously this point is the center of the circle, and let's take this point. Remember, this is all the values in the list. I just need to convert that into tuple of points, which is what the center of the circle, and the radius, let me take the 3 pixels, and the color, I just want the green color. In order to create the green color, it is 0, 255, 0. And finally the thickness of the image, thickness of the circle is -1. Now let me execute that. Here we go. What you can see is that we got the face, and what we got the landmarks of the face. This is what the landmarks of the face. It's nearly nice, beautiful, right? Model can able to detect the eyes very accurately, and the eyebrows, chin, and even the nose positions. This is really awesome thing, right? With that, I think we are really able to get the features from the face. And what we need to do is that we just need to convert that into 128 dimension. That we are going to see in the next lecture. Until then, happy learning. Welcome back. The final process in the feature extraction is to compute the descriptors. So now let's see how to compute the descriptor using a deep learning model. So we have another model called shape descriptor, which will basically calculate the face descriptor. So let me use this. Now let us calculate the shape descriptor. Shape descriptor dot compute face descriptor, and here I just need to provide the image, basically to which image I just want to calculate the shape descriptor, and also the face shape. We just need to provide the shape of the face. With that, what you can get is that face descriptor. And now execute it. Done. So what now you can see that the face descriptor, this and all the face descriptor which is in the dlib format. You can convert that into the array using np.array. With that, we can able to get the face descriptors. This descriptor is used for the classification model, or means in order to train any machine learning model, the input for that model are this face descriptor. And here you can see the length of that, it will be equal to 128. Here you go, we are 128 dimensions of hypersphere. So this is how we can able to extract features from the faces. I will see you in the next lecture more on this. Until then, happy learning.